Nan, all you.
Thank you. Can you hear me? Yep. So my name is Nandagopal. Nan is my user-friendly name. It's really long, so I just go by Nan. Today we'll be talking a little bit about the data quality and reliability, and what AI can do, and why should you use AI, right? We happen to have quite a few data clouds that we manage for customers, and as we are putting those things together, you want to catch data problems early on, and as we are trying to do that, we had to write scripts, rules and so on. So from that, years of running these data clouds, about 25 years or so, right? So there's some accumulated knowledge that we've kind of distilled all that together into a platform. I'll be using some screenshots to illustrate some of the patterns where AI meets data quality and reliability as I talk through some of the patterns today. So the problem of data quality itself is timeless. I can remember 25 years ago working on a big data set, telecom migrations that we used to do. We had to write a lot of validations, all business rule validations and so on. And in fact, we had a patent for a data validation framework at that time, working for a large telco. And those days were simpler, though the volume was high. The simpler data was simple. The rule-based checks, those were what we were implementing, and they were about 10 to 50 checks that we would do every time we would do data migrations, and we would score based on that, the quality of the overall data. The focus was mostly on objective dimensions of data quality, like the consistency, completeness, business business rules, validity, and so on. Right. So really, data quality pursuit was there even prior to 25 years ago, probably 40 years ago. The stakes are higher than ever today, right? So it's not really new, but data quality and reliability is high. So you might ask why, right? So I'm not trying to convince you data quality is important. This whole conference was founded on that notion of data quality and reliability. There are certain things that's changing today. Let's explore a little bit of that. If you look at data complexity versus criticality, right? There are like those two dimensions are shifting, and both are shifting uh, in the same direction, adding, making it a lot more important. For example, take 2 years prior to COVID. Everybody was focused on amassing data, right? Data is gold. We had to bring all of the data together inside data, big data kind of a concept. But the problem was really what kind of value were you driving from the data? So that became a key question during COVID, where everybody was looking at analytics. How can you guys help us, go through the ups and downs of post-COVID situation? So we got better at that. We were able to drive more dashboards in the analytics and data models and data science and all of that using that data that we have today. But what's coming is more pronounced. The agents, right, are easy to write. Much like how you would create a document, you should be able to create an agent. Agent basically kind of takes the data that's been augmented within your large language model, and it can take certain action. So because it is so easy, that action can be integrated into your workflow very, very quickly. So as owners of these data assets, we have to keep an eye on the data quality. Otherwise, the rate at which it will get consumed in the next 6 months to 12 months is going to increase dramatically. And that's because you will be able to leverage that the value of this data in a much more democratized way, and also you're making it easy to kind of infuse that into your workflows, driving efficiencies and all of that. So agents are composable and offer rapid value, so that will they'll all lean on your data and the quality of the data in your systems. Streaming pipelines and also the complexity of your upstream producers is always going up. There are multiple apps and multiple sources of data that we are all bringing that together. And even downstream consumers, we were always looking at reports and dashboards. They were humans consuming that. Now you might even have machines or agents consuming the data as well. So bad data moves faster, much more faster, and breaks more things today. As agents get easier to build, the cost of bad data goes way up. So that's kind of the hypothesis here. Data quality has always been there, and why we should pay a lot more attention. And the traditional ways of paying attention really falls a little short. So, for example, we back in 2000, it was all based on heuristics. It was based on subject matter expertise. I knew the telecom domain really well. I could anticipate the kind of problems, and I could write business rules, and I could check for it. That kind of convenience or comfort may not be there today, right? Because of the rate at which the data is going to get consumed, I can't, you can't rely on me to foresee these problems and write those checks. So you almost have to have systems that detect problems as and when it's happening and also cure it, right? You have to get out of this reactive mode, and also the unknown trap. I don't know the kind of problems that the data might you might see, and so you will have to catch these unknown problems, right? So it's not necessarily heuristics. We can't write rules for problems we don't know that exist yet. So that's the a little bit. So AI is a game changer for data quality. It can recognize the patterns, we all know. So there's a lot of time series data sets you can put in place. For example, you watch a table multiple times in a day, and you see how many rows are in that table, and you kind of store it. It becomes a time series data set, and then you can apply anomaly models on that, and it can catch certain problems. Rules and alerts, right? You want to write rules, it's complex. Still, you are a subject matter expert, but you don't have to know the whole ways and means of writing those rules. You can just talk, and you can produce some of those rules, and even alerts as well. Prevention and root cause. Similarly, when you find a problem, you also have to be able to go fix the problem. So AI can go and figure out adjacent patterns and kind of assemble an incident together, and then put it all well together for your data engineers to kind of take a look at it and go fix the problem fast. Finally, it's adaptive. It can also learn, right? So based on your data patterns, over a period of time, it kind of adapts and begins to learn on its own. And we'll go into some of those patterns. It'll become a little more clear. I have about 4 or 5, 6 patterns actually, and we'll kind of go through that really quick. So AI powered anomaly detection. I'll be using screenshots from a product that we've developed, and I'll kind of introduce the product towards the end. The anomaly, every time you have an agent, and we kind of go and look at certain parameters on your data assets. So for example, we look at your data warehouse or data lake, and we look at all of the tables. We can look at the volume, the freshness, schema, the distribution associated with those tables. So what I mean by that, right, is the amount of rows in a particular table. It's increasing in a certain way here, and suddenly it falls off. Therefore that is an anomaly, right? And it can capture that, and it can bring it to your attention. This is not something each of the humans are sitting there and watching all the tables. It's not possible, nor it's worth their time to do that. So that's kind of where the AI powered anomaly detection comes. It learns normal behavior. This data patterns might vary. On a couple of weekends it might fall, pick it up on a weekday type stuff, and it can learn all of those normal behavior patterns. So really this is about figuring out what humans might miss. More so, humans may not have time to go look at all of the data at that nascent level. So that's pattern number one. Pattern two is for root cause analysis. Here, we've found a problem, but we want to also see what other information can we unearth from that. So basically, the root cause, looking for adjacent patterns. So for example, a pipeline failed, and the pipeline failure caused a volume anomaly. So you can see the volume anomaly and the pipeline failure. And pipeline failed because there was a schema changed. That was an upstream application that changed the schema. So if you can cluster all these things together, that would be a gold mine of information for a data engineer to go and fix that particular problem. So here you will see that AI is basically figured out that kind of a clustering, and it actually gives you a summary. It's an English description of all of the problems. It's figured out, okay, this failed because of that, and upstream or downstream systems, puts it all in a simple English form with logs, right? And you can click through and kind of go through the log information and can fix your problems quickly as well. So solve the data problem, you need to know where it comes from. And so it also kind of gives you an upstream lineage and downstream of where the epicenter is, where the problem occurred, and what were other problems that came. And it kind of, can give you that context for the data engineer to fix the problem quickly. So that's pattern two. Let's see a pattern three, right? You really have to keep an eye on the overall reliability. If agents are consuming your data, you have an LLM and you've augmented that with your own enterprise data, and all of the agents are going to consume that, you want to keep an eye on the reliability. You want to really have a number to it, and you want to be able to watch that number and see how that varies over time, right? And there are many systems like this. All of them try to quantify the reliability or data quality of your assets. This is one such effort. So we take multitude of factors, freshness, volume, schema, distribution, and all of that, and sort of come up with this number which is dynamic. Because data, when it's not moving, there's a decay as well. So it also accounts for that, right? And so your score may just go down even if there is no data coming into the data lake, because the freshness factor may fall off, right? So that's kind of where a little bit of AI also could be used, but trust should be measurable. So that's another aspect of sort of something to keep in mind as to kind of measure the reliability as you go forward. AI driven rules generation, that's another pattern. Here, you can basically uh, use your subject matter expert, and usually they are well trained and they can write their own SQL whatnot or write scripts, right? But interface like this just provides a simple language like interface, so you can really talk to it. Hey, I want to monitor, I will write a monitor or a rule, uh, uh, so that there is a profit check on a particular item that's being sold. What's the cost price versus list price? And then you can kind of write a rule like that. So as you give it and it'll generate a SQL for you, it can generate pretty complex SQL statements across domains and schemas and joins and so on, right? Can help. Pattern number 5, right? So this is about remediation. So when you talk about monitoring or observability or data quality, you're simply talking about observing or notifying when data is going bad. That's great. No, but that's not enough, right? You want to also have the systems fix the data. So that's kind of the life cycle: monitoring, detect, notify, and fix. Fix is where AI can also play a major role. In a simple way, what we are doing is, having there's an LLM that gets trained on your asset, the schema, and it kind of contextually understands the schema, can understand the columns. It can also understand the domain, if you're in transportation, finance, and so on. And it can connect dots and bring certain rules to your attention. Hey, you may want to turn this rule on, right? And so you will be able to kind of click and turn that rule, and the system begins to monitor that piece. So this is almost where the machine is beginning to give you a set of rules, as opposed to you setting it up and running that type of stuff. In addition to that, right, fix can actually go even more deeper. So what if there was a component or a shelf of components where you can fix your data problems? So a customer where we had to do some brand normalization on their marketplace, that's each time vendor would come and dump their catalog, that would cause problems with the user experience, because each vendor on the marketplace would have their own brand names and do spelling mistakes and whatnot. So we had to normalize that. So what if we could read that and normalize on a regular basis, right? And then based on the augmentation, the automation slider, completely make it autonomous, or where you fix and write it back to the database. or human in the loop, or just notify me when there's a problem. So you can have this autonomous slider. Based on that, it can take different forms. But that's kind of where we are going. That's kind of on the roadmap towards creating self-healing systems, where you as a user can choose what degree of autonomy you provide to the system, or what autonomy you want to retain with yourself. Going on, the last pattern here is LLMs and data quality. LLMs are, the key from a data quality standpoint is that they understand the human intent, right? And they also understand the business context and the domain meaning. So they actually bring a human-like perspective to data quality. So, for example, we have an agent which is looking at the tables, and we are sampling the volume every single time. That's an agent. But what if there's an agent that really understands the language, right? And so it can think like us, and it can actually look at the peripheral issues around the data, right? Not just the volume or schema or freshness, but it's actually looking at more of the factors that make meaning to humans, that type of thing. So it can go beyond the bits and bytes and interpret semantics, and enable autonomous proactive data trust. And the challenge with that is LMs may not still be evolved for petabytes use, because that much of data, it'll take you time and it'll cost you a lot of money to process and efficiencies, all of those. As it continues to increase, we have to just keep up. But for now, our roadmap is about how do we get close to that self-healing capability, but with full controls, right? So you can basically set which level of autonomous nature do you want to have there, type of stuff. So short answer, not, but the quantum thing is fascinating. The previous talk that I had, that goes into a very, they talk about sacred geometry and some of that. That's and how binary systems are not. Uh, Not because somebody made a comment. Brain takes what 40 watts of power to do that much, and each data center consumes gigawatts of power, right, to do the same thing, but not as much as close to brain. So there is something flawed in the fundamental architecture, right, in terms of how you are approaching compute. But that's a whole different topic. I don't think I'm qualified to even talk about it, but it's fascinating. So.
Yeah, I think so. I'll add a little commentary, right? I think the reality is multi-agent systems and the solutions, and when you have agents learning off of other agents and the pace that they're going to move and evolve at, and then you have quantum computing powering the back end of all of this, right? Having a tool like you're talking about and its ability to detect and self-heal is going to be critical, right? Mm-hmm. I mean, I think that at some point, everybody who's in here and operates an ongoing concern needs to be concerned about those things, their independence, number one, and the pace they're going to move at in the future versus how they move now. So if you're not doing this kind of stuff today, and by the way, I don't work for Co-Strategic. I don't even work for a partner. I just happen to know Mark Johnson pretty well, right, and Colleen. And the reality is, I think these are the kind of things that you're going to have in place in the future in order to keep pace with what's going on in the world.
Thank you. Thank you. Thank you.
Any other questions? Oh, here we go.
So I think it's a misconception to think that the LLMs, have any kind of artificial intelligence that would be competitive with, human-computer hybrid, intelligences. So I'm curious about your thoughts about what are good patterns of combining, the human and the machine intelligence around, data quality, reliability, and so on.
So one of my patterns actually talk to that, right? So I mean, we're not pushing the boundaries of the LLMs yet at this point. When you do implement those agents, so for example, we have a agent called Q agent, right? It's what is its job? Is to kind of watch the database and say how many tables, okay, what are the schema, I write it down, right? If I'm a agent, like this is a structured program that basically runs there. How many rows today, right? What's the freshness? So I would write down everything is time series data sets, right? So that's what a computer was able to do. But what if there was a agent that is based on an LLM that's watching it, right? So you might give it prompts like, this is actually a retail data set. Catch any problems around retail, right? That you can think of that is going sideways, right? And so we have to program that in, put some guide rails so it doesn't go too wide, but it can do things like that, right? And so it can see commissions. It sees a particular product was being discounted at 50% or more multiple times, and it can catch that. You will have to write a rule for it, but an agent with its current understanding of the way the world operates, it's able to catch those type of things. And so it'll bring that as a recommendation to you. And now you are human in the loop. It's a co-pilot, not an autopilot. And so you can say, okay, I like that. Let me turn that on, right? And so, and then you can turn it on and customize it further. So it's assistive technology. It's also looking at things. Now you might have somebody on the team who is a great data engineer, but he's not a retail or a domain or a finance or legal expert, right? So this kind of a tool can actually bring those rules where they may not have the domain knowledge and can be assistive in that form. So it's kind of a low hanging fruit. There might be much more juice to squeeze as we go.
So basically, you're recommending use an agent to come up with some rules, but then kind of rely on the human in the loop to kind of review the identified like a ranked list of identified issues.
That's right. Yeah.
Thank you.
All right, so we're at 5:45, so it's time for us to go and have drinks over in the reception area. I think it's been a great day. Thank you again. It was a great
Thank you all.
presentation.
Thank you.
Okay, and he'll stay around to answer any questions you may have after, if there are any. And we will see everyone in the ballroom. It starts now. Everyone should have drink tickets, which are those little drink tickets. You get one free drink. And if not, we'll see you tomorrow. All right, thank you.